Okay, friends, today our topic is hydrothermal ore deposits. The term hydrothermal means hot water with possible temperature of 50 to 500 degrees centigrade. The fluid resulting as an end product of magmatic differentiation constitute hydrothermal solution which carries metal originally present in the magma. This process is responsible for the formation of the epigenetic deposits. Actually, the epigenetic deposits are those deposits which are formed after the formation of the host rock. The epigenetic deposit formed by hydrothermal solution are called hydrothermal ore deposit. The ore deposits which are commonly formed by the hydrothermal process are gold, silver, copper, lead, zinc, and mercury. Now, what is the classification of the ore deposits? On the basis of the depth and the temperature of the deposition, Landgrens has classified the hydrothermal deposits into three groups. Number one is hypothermal deposits, second, mesothermal ore deposits, and third, epithermal ore deposits. Now, what is hypothermal ore deposits? Okay, we'll see. Hypothermal deposits are formed at great depths and high temperatures and pressures. Temperature may range from 300 to 500 degrees Celsius during the formation of such deposits. Ore mineral found may include native gold, sulfide, galena, chalcopyrite, pyrite, molybdenite, bismuthnite, and arsenopyrite. The oxide, uranite, casterite, magnetite, and the tungstate, wolframite, and slate. Metals which may be extracted from hypothermal deposit consist of copper, molybdenum, tin, tungsten, gold, and lead. Second is mesothermal. Mesothermal deposits form at intermediate depth, temperature, and pressure. Temperature may range from 200 to 300 degrees Celsius during the formation of such deposits. Ore mineral which may be found include native gold and the sulfide galena, sphalerite, chalcopyrite, pyrite, bornite, arsenopyrite, and tetrahydrite. Metal which are mined consist of copper, zinc, silver, gold, and lead. The third type is epithermal deposit. These deposits are formed at shallow depth under relatively low temperature and pressure. Temperature during formation may range from 50 to 200 degrees Celsius. Metals which are mined from epithermal deposits include silver, gold, and mercury. Now, the second classification is based on the mode of the formation and the genesis of the deposits. Hydrothermal deposits have been classified into two groups. Number one is cavity filling deposit, and second is replacement deposit. What is cavity filling deposit? These deposits are formed when hydrothermal solution deposits their dissolved mineral in the various type of opening present in the rock. In this deposition, no replacement is involved. Such a deposition takes place by change of temperature and pressure of the hydrothermal solution. Most of Epithermal deposits are cavity filling deposits. Type of cavity filling deposits. Depending upon the nature of the opening, the cavity filling deposits occur in a variety of size and shape. The common type of the cavity filling deposits are fissure, vein, shear zone deposits, stockwork, saddle reef, ladder veins, and Q deposit and gauge veins. Now, what are fissure deposits? Actually, these fissure deposits filled with when fissures are filled with ore is called fissure veins. It is tabular ore body which occupy one or more fissure within a rock. Fissure veins deposits are the most important of all the cavity filling deposits. They are the chief source of most of the metal like gold, silver, copper, lead, zinc, and mercury. The common type of the fissure deposit are as follow: simple fissure veins and chamber vein. What is simple fissure vein? Acidic rain which occupies a single fissure whose walls are nearly straight and parallel is called simple fissure vein. Chambered veins are those veins whose walls are irregular and brachiated are called chamber vein. Such vein branch and join as shown in figure. In this figure, figure A, this is chambered veins, second is a lenticular vein, and third is a sheet vein. Dilation or lenticular vein. Generally in schist, which is a metamorphic rock, several disconnected lens of the ore occur together. Such lens are called dilations vein. Their width range from a few centimeters to tens of meters. Sheet veins, a group of closely spaced parallel veins are called sheeted vein. In this case, all the veins together form and low. Composite veins. A composite vein is a wide zone of nearly parallel fissure. The width of such vein is measured in many tens of meters. Shear zone deposits. Shear zone deposits of thin and closely spaced fracture here as opening are minute, the opening space deposition is minor. However, the large specific surface of the opening make the shear zone very susceptible to replacement. Hence, many large and valuable ore deposits are formed in this shear zone. Stockwork. Stockwork is nothing but it is a mass of rock traversed by a network of small ore bearing veins. Stockwork are formed when the hydrothermal solutions percolate through vertical zone of intense shattering which occur in certain igneous intrusion as shown in figure 3. This is stock work. This is the stock. This is the stock work. Now, What are saddle reefs? During folding, openings are formed between rocks bed at the crust of the anticline. Ore deposits formed along such opening are called saddle reef as shown in figure 4. Ladder vents. Transverse crack in dikes formed as a result of cooling and contraction of the igneous masses are due to movement of the wall rock are often subject to mineralization, giving rise to mineral deposit known as the ladder vein. This is the ladder vein dikes. These are the transverse cracks formed in a dike. Gauge vein. Gauge veins are mineralized vertical solution joints in carbonate country rock and contain valuable deposits of metals, metallic and non-metallic minerals. Mineralization along opening in brecciated and vesiculated rock has led to development of copper, lead, zinc and silver ore. This is a carbonate rock and these black spots are your gauge veins. Replacement deposit. These deposits are formed due to chemical interaction between the hydrothermal solution and the country rock. The ore minerals are deposited from a mineral bearing solution in place of country rock, the latter being dissolved and removed in solution. The filling of the rock opening by precipitation and the replacement of their walls may occur simultaneously. Replacement dominate under condition of higher temperature and pressure, whereas cavity filling dominate under condition of low temperature and pressure. The replacement deposit commonly contain ore of iron, lead, zinc, copper, silver, and many non-metallic minerals. Type of replacement deposit. The ore deposit formed by replacement can be subdivided into three groups. Number one, massive deposits, replacement load, and disseminated deposit. Massive deposits are the ore deposit commonly occur in limestone. The ore terminate abruptly against the host rock and characterized by great variation in size and extremely irregular form. Replacement load. The load deposits are formed when the replacement is localized along thin beds or fissure. In this case, the fissure walls are replaced by the ore. The load deposits resemble fissure vein in form, however, they are wider than fissure veins and their walls are wavy and irregular, as shown in figure 7. Disseminated replacement deposits. These are low-grade ore deposits where grains of ore minerals are found scattered throughout the host rock. Thank you.